So, hello guys from the high school. This is teacher Krishna, and welcome to our physics class for week number 13. And before we start, let me thank you all for all of the effort that you have put on completing all of the online lessons and assignments that you have had so far. Because this has been a new transition to another methodology, and I'm pretty sure it's a little bit difficult to adapt. But with time, I'm pretty sure that you will be doing even better. So one more time, thank you all for coming here today, and let's continue. Before we start, let's just follow some general instructions. Log into Agilex, enter to the Google Classroom, download your Word document, and save it in your physics folder. And lastly, you need to name your document in the following way. You need to add week number 13 at the beginning, and then add the rest of the information that we have had in other weeks. As we move, remember to take notes on the Word document. That's very important because that is going to help you keep track of the most important concepts from the video that you will be having today. And it's always important to begin with our ending point. So our ending point for this week is the following. Use information that has been gathered through the module to complete the module evaluation. So today you have to complete the module evaluation number 5. So notice that I have prepared a summary of most of the topics here in this video. So that is going to help you out to remember and refresh your mind from some important concepts and from some things that we have studied already in class. But it's always important for you to go back to the topics and reread them. So you have a clearer idea of all of the information. Okay, so remember, watch the video and refresh your mind with everything we have here, but reread all of the topics from Module 5. And just like I told you, I prepared a summary of most of the topics, but you have to reread the last topics in order to have that present for the evaluation, okay? Moving on then. We're going to start with electric circuits and forces. So the first thing that we encounter in there is the definition for conductor and insulators. So remember that a conductor is a material that will let electricity flow and with no difficulty at all. But in the case of insulators, they are materials that do not let electricity flow through them. So an example of a conductor can be iron, and an example of an insulator can be rubber. Remember that a circuit is a constant loop of energy, and a circuit must have a source of energy. Because, for example, if we have a battery, then that is going to supply the rest of the circuit with energy in order to function correctly. Here we have a very simple example of what a circuit looks like. As you can notice, there we have a battery, and also we have a switch and a light bulb. That is the most common example of circuits. But of course, there are many others and many other kinds. Alright, and also we find this image in the platform, and that is an example of several conductors and insulators that we have in a light bulb. So if we go right at the top left corner, we find that the filament that is right in the middle of the light bulb is a conductor, and that is the part of the light bulb that produces the light. Also, if we go a little bit below, we can find that the glass is an insulator because it will not electricity simply flow away, because that might be dangerous for humans. So even though it heats up a lot, it does not let electricity flow through it. And if we go to the left, a little bit back, we have a black ring that is an insulator, and also we have a tip that is a conductor. And lastly, at the bottom, we have a threaded section, which is a conductor. So just like you can notice, in a circuit or in a light bulb, you are always going to find conductors and insulators because they both work in order to create a certain function that in this case will be producing light. And also we're going to talk about charges or magnetic fields. Remember that magnetic fields are constantly affecting objects, not directly because they are touching, but because of the magnetism that they produce. So we talked about it in class, and remember that similar charges repel each other, but different charges attract each other, just like we can see it in here. In the image is represented the attraction of two different charges. So we need to remember a little bit about the Coulomb's law, in which we have this equation to find the total force of an electric field, just like this one. So we have that the force of the circuit will equal the Coulomb's constant. We have the charge in number 1, we have a charge in number 2, divided by the distance square. That's something that you need to keep in mind as well. Also, we have another formula that helps us out to find the electric fields. So electric fields will equal force divided by the charge. Okay, those are two very simple formulas that we studied in class, just for you to have them in mind. Let's go with electric current and magnetic field. So electricity is usually invisible, and it is stated that it's usually invisible because there are a couple of things that we can actually see with our naked eyes. For example, if you rough two pieces of cotton, sometimes it's possible to observe some sort of sparks that generate light. So that is basically electricity, but usually it's not something that we can observe. You can see it through a light bulb or a magnetic compass. So, of course, with a light bulb, when electricity flows through the conductors, then it produces light, so we can see it in there. But the magnetic compass is a tool that helps us out to measure the magnetic fields and also the electric currents in a certain object. The magnetic fields are detected by the deflection of the compass. It is caused by the motion of the particles. So remember that we studied that electricity is produced when atoms start exchanging electrons. So, of course, if electrons are moving from atom to atom, they are moving, and they produce a magnetic field around it. So, and magnetic compass helps us out to measure the motion of the particles and the amount of the magnetic field that has been produced. And it can also indicate the direction in which particles flow. We're going to learn a little bit more about the direction in which particles flow a little bit later on. Direction of current. So it is possible that an electric current produce a magnetic field. It is known as electromagnetism. So we have to analyze a term that is charge, that means vehicle. So, for example, if we have a cable that is transporting electricity, and we're going to find electromagnetism around that cable. It might be high, it might be low, but because of the same movement of the particles, then these magnetic fields are produced around cables. Okay, and we have that the charge is transported by the wires, just like I was telling you before. We have batteries. So, batteries are very important in circuits because they are the main supplier of energy. So I found an example in the platform, and they were talking about a voltaic cell. So notice that most of the batteries follow this principle. So it has two poles, one made of copper and the other one made of zinc. Or if you are careful enough when observing a battery, you can notice that they have a positive pole and also a negative pole. So the part that is made out of zinc will have the negative charge, and the one that is made out of copper will have the positive charge. And here's what I was telling you about the direction of the particles. So the energy flows from the negative part to the positive part. And that is something that always happens. So in the case of the batteries are going to start deflecting the energy from the negative part to the positive part. Okay. And here we have a normal battery. Usually the positive part are where the brownish part is specified, and also the negative part is where you can find the black part. Okay. So in this case, as we analyze the direction of the batteries, whenever we connect anything to the battery, the electricity will start flowing from the black part to the brown part, or from the negative part to the positive part. That's something important to have in mind. We are also reviewing the Ohm's law. So to calculate the current or amperage of a circuit, use the equation for Ohm's law. Ohm's law states that current or amperage in a circuit is equal to the voltage in the circuit divided by the resistance, R, of the circuit. So this is something very simple to do, and here is the equation that represents it. So letter I will be amperage, we have B, voltage, and lastly letter R for resistance. And this is very applicable to several problems. Here we have an example. So a small flashing bulb provides a resistance of 5 ohms. To them, 300 milliamps current that runs through it. Determine the voltage of the battery in the flashlight. Okay, so from the Ohm's law, you can write that the voltage, that is what we're interested in, equals I times R. So here if we substitute the values from the problem to the formula, we will have the following. So V equals 0.3 amps times 5.0 ohms. And of course, our result will be 1.5 volts. So the battery has a voltage of 1.5 volts. Right, and now we're going to continue with electromagnetism. So it describes the magnetic fields and their behavior around a magnet. So whenever we talk about a magnet, we have to remember that there is a magnetic field that is always going to surround it. One part of the magnet will have a positive side, and also another part will have a negative side. Okay, so it is represented right here. So we have north and south as well. It can also be represented in that way, because what happens is that there are charges that are flowing away, and that are flowing away a certain part, but that are coming back in another one. For example, in this case, you can notice that in the north part, there are several charges that are going out of the magnet, but they all are coming back inside the south. So in this case, remember that in electromagnetism and in electricity, charges are going to flow from negative to positive. Just like in here, north will be negative and south will be the positive one. We're also going to review a little bit about capacitors. So remember that capacitors are devices used to build up and store charges for further use. They consist of conducting and insulating plates. And one clear example that I can give you is about your keyboard. So each one of the keys on your keyboard have a capacitor, because all of the keys in there have conductors and insulators. So when you do not press them, the insulators are acting upon the keys, because they are not providing the computer with any sort of message. But when you press them in order to type down anything, then the conductors start working, because they start transmitting information to the computer. For example, if I press letter O, then you will see that on your screen there will appear a letter O, because your computer has been programmed to detect that information. Okay. And something that you need to remember is that capacitors are not only part of the technological stuff that humans have created, but there are also biological capacitors in nerve cells. So basically, inside your nerves, whenever you want to do a movement, then your nerves are going to start generating hormones that are going to give your brain a certain information that will help you out to to move a certain limb. Okay. So in your nerves, you can also find capacitors because they follow the same principle. They transmit energy or they transmit information in order to produce an action. And wires are usually connected to the conductors. Because remember, wires are going to transmit electricity. And since we want them to transmit electricity and follow the path, they have to be connected to the conductors. So here we have an example of a capacitor. So you can see those sort of metal tubes that are going right out of it. So they are basically parts that are connected to the conductors, and that of course are going to facilitate the flow of electricity through the capacitor. Right, so now it's time for your evaluation. And one more time, review all of the topics from Module 5. I already gave you an overview on what were probably some of the most complex topics to understand, but it's necessary for you to read the rest of content from Module 5. And when you feel ready, take the evaluation for the topic, or most likely for the module. That is the module evaluation for Module 5. So thank you one more time, guys, for attending our online lesson. It's been a pleasure to have you here with me, and good luck in the evaluation. I will see you next week. Goodbye.